Why are we able to push a wagon or a car or a box when we are outside and move it, make it move? But when we are inside the wagon or inside the car, no matter how hard we try to push it, it does not move. What is the reason? That is the theme of today, which is one of many problems that Newton's laws of motion answers it for us. Before I continue with the subject of today, I want to mention that I publish videos about my travels, daily life, quotes from great men and women. However, I also want to publish well-prepared videos, good videos about different themes with good sources. To distinguish these good videos, I will make them some sort of series, a good series with episode number. They are called Learn and Explore series. And I also will color code them. For example, educational, whether it's about physics, mathematics, chemistry, different nice subjects about daily life, how we can use science in daily life, they will be blue to make it easier for the viewer to choose the theme they like, because the different episode could be different themes: politics, humanities, travel, butter videos that shows you attractions, tips what to do, and so on. Now, let's go back to our problem. Why, when we are outside a wagon, a car, a box, we are able to move it or set it in motion by pushing it? Yet, no matter how hard we try, no matter how hard we push, when we are inside the box, we are never able to set it in motion. We cannot move it away. I'm going to explain this problem to get you, so you get a feeling for Newton's laws. These laws were first fully developed description of nature. They are more than 300 years old, yet they are of paramount importance even today. There are many practical applications of Newton's laws, including from your everyday life, like airplanes, car collisions, airbags in cars to protect you from car collisions, playing basketball, or any kind of ball actually. It plays an important role for spaceships that go and went to the moon. It plays an important role for motion of planets and moons, like our moon and earth system, and many more. So let us state one of those laws. There are three laws, three Newton laws. We are going to state the second law. It is phrased in a different way here than you see it in books, trying to make it easier, hopefully, and to point out important details. So if you are super precise type, remember, it is meant to clarify some points. Here it is. The forces that touch or act directly on an object one object, it could be one force, two forces, or more. They add up together, these forces, to make one force called the resultant force or result force. A better word might be the total force. So they add up and make up one force. Finally, that result force will make the object move or accelerate. The law has a precise mathematical formula, but we skip the formula. We need simple arithmetic to solve our problem. Let us point out some important details already mentioned in the statement of the second law. We just emphasize it. 1. Newton's second law says when you exert a force on an object, it causes it to move faster and faster, or accelerate basically. Second, in real life, you don't have necessarily one force. It could be more than one force. It is not the effect of one force that moves the object. It is the total combination of all the forces on the object that moves it, or the sum of them that moves the object. Let us take 3 quick examples to explain what do we mean by total force or result force. Let us take an example where the wagon is pushed by a force to the right with a strength of 100 Newton. N stands for Newton. It's a unit for force, just like kilogram, pound for weight, or mass to be more precise. For force, to quantify it, we use Newton. So the wagon or the box is pushed by a force, 100 Newton, to the right. In the same time, the wagon is pushed by another force, also to the right, which is 50 newtons. So the force that moves the wagon is not 100 newtons, not 50 newtons, but 100 plus 50 equal 150 newtons. So the force that moves the wagon or the box is the combination force, which is equal to 150 newtons.